What if the networks of tomorrow could think for themselves, adjusting routes, optimizing performance, and even healing from failures, all without human intervention? That's not science fiction. It's the promise of next-generation IP network design. Stick with me, because today we're exploring how technologies like SRv6, L3 VPNs, and virtualization are turning that promise into a reality. Welcome to the Christian Omeni Tech channel, your hub for cutting-edge tech insights. If you're passionate about technology and want to stay ahead of the curve, subscribe now and join our growing community of innovators. So, why do we need future-ready networks? The world is exploding with cloud services, real-time applications like RNVR, and a massive number of IoT devices. Traditional network architectures just can't keep up. They're too rigid and require too much manual work to scale. To build networks that are resilient, programmable, and efficient, we need new tools. That's where SRv6, L3 VPNs, and virtualization come in. These aren't just buzzwords, they are the foundation for the networks of tomorrow. Let's break down the building blocks. First up, segment routing over IPv6, or SRv6. Think of it as a GPS for your data packets. You can encode a list of segments or instructions directly into the packet header, telling it exactly where to go. This simplifies the network's control plane because routers just need to follow the directions. You can steer traffic around congestion, send it through specific services like a firewall, and do it all dynamically without complex manual setup. It's flexible, scalable, and highly programmable. Next, we have L3 VPNs, or Layer 3 virtual private networks. These allow you to create isolated, secure routing domains over a shared network. Imagine each of your customers getting their own private network. Even though they're all using the same physical infrastructure, each customer has their own virtual routing instance, so their internal IP addresses don't conflict with others. And finally, virtualization. This is about running network functions like firewalls, load balancers, and routers as software in virtual machines or containers, instead of on dedicated hardware. It also means we can carve up the physical network into multiple virtual networks, or slices, each tailored for a specific service. This brings incredible agility. You can spin up new functions on demand, scale them out when traffic spikes, and then spin them down. It's cost-efficient and allows for dynamic, programmable service paths. Now, the real magic happens when you combine these three technologies. At the core, you have an SRv6-enabled backbone acting as a high-speed, intelligent steering engine. On top of that, you layer your L3 VPN services, giving each customer their own secure, virtual network. When traffic enters the network, it gets an SRv6 header with a list of segments. This list can direct the packet through the most optimal path, and even steer it through virtualized services like a firewall VNF before it reaches its destination. All of this can be automated and controlled by a central orchestrator, creating a truly dynamic and adaptive network. Let's make this real with an example. Imagine a global company with offices in Lagos, Dubai, and New York. They need a secure, full mesh network. With this new architecture, you can set up policies to send their voice and video traffic over the lowest latency path, while bulk data takes a different route. You can insert a virtual firewall for all traffic leaving the Lagos office. If a link degrades, the network can automatically reroute traffic, ensuring services stay online. This is a level of control and resilience that's difficult to achieve with older technologies. Another powerful use case is 5 network slicing. A mobile operator can build one converged SRv6 backbone and then offer different slices on top of it. One slice could be optimized for ultra-low latency for applications like remote surgery, while another is built for high bandwidth to support massive video streaming. Enterprise customers can get their own L3 VPNs inside these slices. The network becomes a flexible platform for delivering countless customized services. Of course, building a future-ready network isn't without its challenges. You need to consider hardware readiness, as not all routers support SRv6 yet. You'll need strong automation and orchestration systems to manage the complexity. Security is also critical. You must prevent malicious segment lists from being injected into your network. And you'll need a gradual migration strategy, likely starting with a hybrid model where SRv6 coexists with your current MPLS network. So, where is all this heading? In the near future, we'll see AI-driven controllers that continuously analyze traffic and rewrite segment lists in real time, proactively rerouting traffic before users even notice a problem. We'll see intent-based networking, where you simply declare your goal. Like all video traffic needs low latency, and the network figures out how to make it happen. Virtualized functions will move closer to the edge, running on smart network cards for line rate performance. The lines between IP, optical, and wireless networks will blur. With unified control across all domains, you might be thinking, this sounds great for a huge global provider. But why should I care? The principles of scalability, efficiency, and programmability apply to networks of all sizes. Learning these skills future-proofs your career and allows you to build more resilient and automated networks, even in a smaller enterprise environment. You can start by setting up a lab, experimenting with SRv6 and L3 VPNs, and getting familiar with automation to design your own future-ready network. Start by assessing your current infrastructure and defining your service requirements. Then, design an SRv6 backbone, layer your L3 VPN services on top, and plan where to place your virtualized network functions. Most importantly, build out your automation and orchestration capabilities. Start small, test everything, and migrate gradually. In the network of 2030, you won't just be managing connectivity. You'll be engineering intent and orchestrating intelligent behavior. SRv6, L3 VPNs, and virtualization are the tools that will get us there. They represent a fundamental shift from rigid, manual networks to agile, dynamic, self-adapting systems. As engineers and architects, this is our opportunity to build the nervous system for a truly connected world. If you found this deep dive valuable, smash that like button, share this video, and be sure to subscribe to the Christian Omeni Tech channel. We're building a community of innovators who are shaping the future of networking. Thank you for watching, and I'll see you in the next one.